Inside a textile workshop, a moving fabric web pulls towards spinning rollers. One grab, one slip, and the machine keeps feeding forward. Inside a warehouse, heavy castings sit stacked beside a loaded truck. One shift, one sudden release, and stored weight turns mobile fast. In a loading yard, a truck stacked high with oversized sacks shifts without warning. One loose bundle coupled with a shift out of alignment and gravity answers instantly. Never, ever position yourself beside or beneath unsecured sacks. Restrain the load and unload mechanically. High-stack sacks form an unstable mass, and once friction or wrapping fails, gravity takes over faster than reaction time. As a sack slides, it accelerates and turns height into outward force, expanding the fall zone. Soft-sided loads deform and disperse energy outward, carrying momentum into surrounding space. If it isn't restrained, it's already moving. Inside an unfinished upper floor, a worker uses his foot to snap floor panels apart. One panel flexes, releases, and stored energy rebounds instantly. Don't use feet or body weight to break, snap, or lever rigid panels. Do secure materials, use proper tools, and control stored energy release paths before applying force. Using a foot to apply leverage flexes the panel while anchoring one end against the floor. When the material suddenly fractures, that stored energy releases along the line of least resistance. The free section rebounds rapidly toward its original shape, converting strain energy into motion. Because the release happens faster than reaction time, the panel snaps back through the occupied space before positioning can adjust. Inside a narrow construction corridor, a crane remains unintentionally connected as a truck begins to move. One hidden attachment, and the machine is pulled beyond its stability margin. When vehicles and equipment operate in close sequence, never ever allow movement until all mechanical connections, contact points, and unintended attachments are fully cleared and verified. When the truck moves while still mechanically engaged, force transfers instantly through the connection point. The crane's center of mass shifts outside its stability envelope as traction from the truck overcomes ground resistance with no designed release path. The pulling force converts forward motion into rotational torque. Once balance is lost, gravity drives the final motion. Machines don't need speed to fall. If equipment is still connected, motion turns into force, and force doesn't ask permission before it tips everything over. On a roadside sidewalk, a plate compactor hits a hard edge. One bounce, one sudden deflection, and the machine begins moving unpredictably on its own. Never ever run or reposition a vibrating compactor against a curb, step, or rigid edge. Do keep it on level ground and shut it down before changing surfaces or direction. A plate compactor walks using vibration that repeatedly loads and unloads friction with the ground. When the vibrating plate strikes a rigid curb or hard edge, the contact becomes asymmetric. One side catches while the other keeps sliding. That imbalance redirects the vibration force into a sideways hop and a sudden yaw. Each bounce resets the contact point so the machine can rapidly change direction and accelerate unpredictably. With no steering system, the vibration becomes the driver, turning the compactor into a self-propelled, erratic moving mass. Vibration can steer when you can't. Keep compactors off hard edges and power down before repositioning. Inside a roadside auto workshop, activity continues near the open frontage until a runaway tire crosses the boundary and turns floor space into a moving hazard. Control access between roadways and work areas by installing physical barriers, securing loose components, and preventing rolling objects from entering active work zones. A rolling tire stores energy once in motion. When it leaves the roadway and enters an open structure, there is nothing to dissipate that energy. The tire follows the path of least resistance, maintaining speed as long as surface friction stays low. Inside enclosed spaces, impacts with lightweight objects transfer momentum outward, scattering obstacles while the tire continues moving until energy is lost through repeated collisions. Without barriers, the rolling mass effectively turns the workspace itself into part of its travel path. If rolling objects can enter the space isn't protected. Control boundaries block entry paths and never assume the roadway will contain its hazards. Inside a fabrication shop, a forklift presses against a freestanding wall section. One push, and the structure starts answering back without warning. Use forklifts only for their intended handling tasks and never ever to brace, push, or stabilize temporary structures without engineered supports and verified tie-downs. Freestanding wall panels act like tall levers with minimal base resistance. When a forklift applies force, especially higher on the panel, it creates torque, causing the structure to pivot, slide, or fold once friction is overcome. As force rises, the panel's center of mass shifts past its support line, and gravity completes the motion. Once movement starts, the system can't self-correct. Temporary structures don't push back. On an open field worksite, an excavator swings a massive stone toward a site dumper. One transfer too heavy, one shift too far, and stability is lost instantly. When loading or positioning mobile equipment, never ever use an excavator bucket to stabilize or control another machine. Always load from approved positions on level engineered ground. As the excavator bucket contacted and transferred weight, uneven ground resistance amplified lateral forces. Instead of remaining stationary, the dumper reacted against the hard surface beneath it, converting vertical load into uncontrolled horizontal motion. Once traction limits were exceeded, the machine moved unpredictably, driven by stored kinetic energy and leverage from the elevated load rather than operator input. On a wet loading dock, a suspended log of wood shifts on a flatbed. Gravity decides the next move in seconds, and the motion accelerates immediately. Never ever stand or walk alongside unsecured cylindrical loads. Do chock, cradle, or mechanically restrain rolls before releasing chains or binders. Cylindrical loads store rotational energy, and once restraints are loosened, even a small shift can convert that stored potential into rolling motion. On slick or sloped surfaces, friction drops sharply, allowing the load to accelerate sideways off the trailer. And because the load is round, there is no stable resting edge, only continuous rotation. So once movement begins, the center of mass keeps migrating until the ground or a barrier stops it. Round loads don't fall, they roll. Inside a busy workshop, a grinder meets metal near sealed equipment. One spark, one unseen condition, and the space reacts instantly. When performing cutting or grinding near equipment, never, ever assume the area is safe. Verify surfaces are free of residue and move ignition sources into a controlled zone. Even without open drums, flammable residues can remain on surfaces, tools, floors, or nearby equipment from prior use or spills. Grinding generates high-energy sparks and sustained heat capable of igniting these residues or vapor traces. Once ignition occurs, flame spreads rapidly along contaminated surfaces and through nearby air, driven by heat transfer, airflow, and vapor concentration. The reaction accelerates outward from the ignition point because stored chemical energy meets a sudden ignition source in close proximity. In a narrow commercial kitchen, steam builds behind stainless steel walls. One unseen pressure surge and the room turns hostile without warning. Block, seal, or overload cooking vessels or steam systems only when pressure can vent safely. Don't forget to share what you learned today in the comments. Your insight could save a life. Take care.